I ran out of time on that first screencast, so I'm going to do part F in a new screencast. And part F is down here. What's the internal rate of return of becoming an ophthalmologist as opposed to an accountant? And for that, they give you the definition and a hint. And let me just go to the definition that we need. This is straight out of the text. The internal rate of return is going to be the rate of return that makes the rate of return to being an ophthalmologist just equal to the rate of return of being an accountant. And of course, they use physician and surfer in their example in the text. But and they use some other confusing notations. If you've ever taken a finance course, they use I, which stands for income. If you've taken a finance course, you're probably used to seeing benefits in period T, capital B, the way I've seen it typically, and costs in period T, and they use I, and they use a negative I for the expenditure in that first period of being in the current period if you want to be an ophthalmologist. It's a little bit confusing notation if you've taken a finance course, but if you haven't, then let's proceed just naively using this notation and this definition. All right, so what do you do? If you have a powerful calculator and you know how to use it, I have never had one and I don't know how to use them, so I'm lost there. But several of you do have the cool calculators and know how to use them and can just input the formulas and get the calculator to spit out R star, and that's fine. Just enter this formula. Push go on the calculator and boom, you get your answer. Team 2 did it that way. I don't know how to do that. I don't have such a calculator, so my preferred way to do anything like this is a spreadsheet. And so here's what I did, and you can do the same. And there's an online equation solver, and some are easier to use than others, and just hunt around. That can work fine too. You just have to be real precise and careful about how you enter the formulas. Anyway, the way I did it was with a spreadsheet, which is pretty unsophisticated, but it gets the job done. So let me show you what I did. So what I did is R has to be between 0 and 1. So I created this column of rates of return that might be the one that I'm looking for, and I did it by thousands. Just input a number, a range of interest rates from 0.001 to 0.999. Some weird things happen at 0 and 1, so I didn't want to do that. Then I don't like dealing with infinity. And I know one of those endpoints gets me to infinity. I'm not interested. So anyway, so what I did was then just input the formula, and you see the formula bar. I copied a wide enough section so you can see the formula. I had named my spreadsheet where I had all the raw data, 511A through E. It's a little bit unfortunate because as you're debugging a formula, you want to be looking out for signs, and that negative is in the name of my spreadsheet. That was a little confusing. I'd recommend a better naming system for you. But anyway, what I did is I just entered that formula. The first value was undiscounted. The second value was discounted by the discount rate. That's what this is, 1 plus that discount rate. And then I anchored that cell reference. That's what that dollar is. And it was to the power of 1, so no power. The second, the period 2 value, that was the third, period 0, period 1, period 2. Period 2 is the value in that cell, but discounted by 1 plus the discount rate squared. And then the final value is discounted by 1 plus that discount rate cubed. And anyway, I did that, and I pulled that over to make the similar formula for the account, and that's why I had to anchor all these cell references. Also, I'm going to fill down, so I had to anchor those cell references. I anchored the cell references to the values too. Anyway, I pulled that down and then I used the fill down command, and I got net present values for ophthalmology and for accountants for all the possible values of R except for the very endpoints. And then the first step, you could just hunt and peck and find where those two are equal or roughly equal. And what I did first to just guide me is I graphed those functions. So you see this, the red is the net present value for the accountant earnings at various discount rates. That's on the x-axis. And then the blue is the net present value for various discount rates of the returns to being an ophthalmologist at various discount rates. And what you see is for low discount rates means that future values are big. They're not discounted by as much as they might be at higher as they would be at higher rates, at higher discount rates. So for low discount rates, those are forward-thinking people. Those are the ants, and we see for them the returns to ophthalmology are higher than the returns to the account. So people that are forward-thinking are going to prefer ophthalmology, and then past some point, where that's the internal rate of return, where the value of R that equates those two. So I know I'm looking for something bigger than 0.1, smaller than 0.2, a little closer to 0.2 than to 0.1. 0.1 is right there. So it's like 2/3, 3/4 of the way over toward 0.2. So I'm going to go look for that precise value in a moment. But anyway, just to show you graphically, the grasshopper, this is the grasshopper zone of R, and then, the ant zone of R, low discount rates, relatively speaking, and then higher discount rates, that's the grasshopper. So at low discount rates, we see the returns to ophthalmology are higher. At high discount rates, better off being an accountant. All right, where they're just equal, that's the internal rate of return. It's going to be 1.175, something like that. That's 17.5% discount rate. Now, 17.5%, that's a really high real interest rate. So at market rates of interest, real interest rates tend to be, over the long run, 2.5%, 3%. Now they're even lower. Anyway, 17.5%, a lot of people would prefer being an ophthalmologist than being an accountant if these are actual earnings. All right. Moving on, what I then did was just hunt and peck. I knew I was in this range. I just scrolled up and down my list. Then I filled in. I just increased the degree of detail. I went to 10,000ths and then to 100,000ths, so I could get a precise value of R. And in the end, it's 0.17257. So 0.173, 17.3% is the discount rate that's the internal rate of return of ophthalmology. So it's you got to be careful entering the formula, but in the end, at the end, it gets the job done with in a fairly unsophisticated way. I'll say one more thing. I wasn't particularly clever about how I designed my spreadsheet calculation. I know there was several more elegant ways to do it in Excel. So if you are a little bit sophisticated in how to use Excel, you can use like a goal seek. Just input the two formulas and do a goal seek for where the values are equal, or input the one formula and do a goal seek for where the difference between the two net present values is equal to 0. And anyway, there's some more elegant ways than I did. Just to show you one more thing that's going on here, to help me find where those two are just the same, I did compute the difference between those two rates of return and just scroll down. You see it's positive difference, NPV-O minus NPV-A. It's real high, real big in the early. It gets smaller, gets pretty darn close to 0, right at 0.173, and then becomes negative and gets to be a bigger negative number. That's what's going on there. All right, that's how you do it. It's the good thing about brute force method in spreadsheet, even though there's a lot of calculations, Excel does tens of thousands of calculations a second. So even though it's brute force and a little bit inelegant, it doesn't take very long.